Hi, in this video we're going to talk about how to use MATLAB scripting in SystemVue to extend the power of SystemVue RF analysis using Spectrasys. So in order to use this lab, you need two documents. One is the Spectrasys VGA for constant P out, the PDF file, and then the second one is the SystemVue workspace. Both these files can be downloaded from the Keysight Knowledge Center. So in this video, we'll talk about two aspects of this example. The first one is how to run this example right here in order to simulate a VGA for a constant output power. And the second part, we'll talk about how this workspace was constructed and the MATLAB code behind designing this VGA. So this page here called design steps right here has 5 steps. The first step is to import the ADS MDIF file, which has the data for the amplifier. So the first step is to import this MDIF file by using this menu here called File, Import, ADS File, System MDIF file, and then you browse to the VGA MDIF file right here. So once you import that, you should see the MDIF file as a data set. So if you look at the independent variables, there are two variables called RFAMP and VCTL. And this information comes from the MDIF, and then these are the dependent data which is also in the MDIF file. The second step in this lab is to set the VGA data MDIF file using this variable. It's in the setup equation right here. So set it to whatever the name of your MDIF file is. And then in order to make sure that the example is able to use the MDIF file correctly, first we need to set the parameters right here. So in this case, we're going to be sweeping the input power from -70 dBm to 10 dBm in steps of 2. So you can use these sliders to set that. And then the second part is also to use this variable right here to set the desired output power, in this case -30 dBm. These sliders are constructed by using the slider button from the annotation toolbar. And if you look at this slider here for P start, it's actually using the variable P start in this equation setup. And the min is -100 and the max is 100, and then the number of ticks is 10. And these variables are in this setup equations right here. So once we set these parameters, the third step is to simulate the VGA using this the schematic and the analysis in this folder right here. So that's step 3. So in step 3, you can click on these buttons, for example, simulate VGA. So this simulate VGA button actually calls this code here, my analysis run analysis, which is this analysis right here, system 1 right here. And then you can click on this button here to open the graph, and then click on this one to close it. The reason for step 3 is to make sure that this design is able to read your MDIF file. And if there are any errors in the MDIF file, this step 3 should be able to point to that error. The next step is step 4, where we are going to be sweeping the design with the independent variable freak, and we do that by clicking this green button here again, and this goes through this variable called FC, which is part of the setup equation, and then sweeps from 12 to 18 gigahertz. So once we do that, you can look at the data right here. So all the data comes from the MDIF file. So again, this shows if the MDIF file has been constructed properly, and also to examine the MDIF file to look at the data. And once we examine the data, then we can click on this button here again to close all the graphs. The actual design part of it is right here, and that's this step here called step method 1. So in this case, this button here, method 1.1, sweep P in for VCTRL. So we are going to be clicking this button actually sweeps this sweep here called top sweep P in, which in turn sweeps this sweep underscore VCTRL. So we're not going to be clicking this because this takes a long time. The data has already been generated, so which is stored in this data set right here. This step here, if you right click and click on the properties, it's actually the one which designs the VGA for a constant P out. So here what we're doing is we're calling this MATLAB function right here, which is right here, find VCTRL sweep method, and that goes and calculates. And if you look at the data or the MATLAB code, that's the code which gets executed. So click that, and that could take a while to simulate. So what's happening is in this code, we get the data from this step right here, and then we look at the control voltage, and then for each input power, we look at the data, which is the output data, and then find the crossing for the P out, and that's what this code right here is. So here, if you look at that code, this analysis is actually run here, called run analysis system 1. So it goes through each P in and then gets the corresponding control voltage, which gives the minus 30 dBm P out that we set in step 2, and then it runs the analysis and then takes the data set and then reads the output data, in this case the DCP and cumulative gain, and then stores it in these arrays. So once the simulation is done, then we can plot all this data that's stored here by clicking on this button. So this plot shows right here, shows that the P out is minus 30 dBm right here between these two input powers, and then this is the corresponding control voltage right here, and we are showing gain and noise figure versus P in right here. So this is a way of using MATLAB for extending your design capability in SystemVue. So in this section, the section will be talking about the workspace structure and how this complete example or design was constructed. So the first one is the data file VGA underscore dat.mdiff, and that's this data file here. As long as you keep your data in this format using these variables, this example should be able to read that MDIF file and use it. The schematic right here in this folder has nothing but a simple multi-source and an RF amplifier, And then if you click on the RF amplifier, it shows all the parameters. These parameters are actually obtained from the MDIF file. And this equation here, right here, talks about how the MDIF file is read and the data from that MDIF file is used to set these variables. And these variables, for example, cval is the one which is used for the gain. So right here gval, and then nfval, and so on and so forth. And the system analysis right here does a Spectrasys analysis. So if you click on that and you look at the path, that's the path right there. And when you do a sweep, A3 sweeps, that's this folder right here. And if you look at that, it's sweeping frequency FC, and that's what that is. And this corresponds to clicking this button here, sweep frequency VGA, and that's when you click on that button, that's the sweep which is run there. And then the next folder, method 1 sweep VCTRLPin, which is right here, is the actual heart of this whole design, where it's calling the MATLAB file and our script, and actually designing the VGA, which corresponds to these buttons right here. So the main algorithm for that, or the code, is this one right here. And that's the MATLAB code, which goes and looks at the data set from this step right here, and like we saw in the first section, runs the analysis corresponding to the control voltage, which gives the constant P out, and then stores the data. So that concludes this example. Again, you can download these files from the Knowledge Center. Thanks.